billions of years, the Earth held the secret to the hardest structure in the universe, deep within its burning, pressurized heart, hidden from human eyes. But today, the silence of the deep Earth is being replicated. We are no longer waiting for nature to grant us these precious, shimmering geometric wonders. Beneath our feet, at unimaginable depths, carbon undergoes a violent transformation, forged by the weight of mountains and the fire of the planet's very soul. The difference between common dust and a priceless treasure is nothing more than the arrangement of atoms under the most extreme conditions known to man. We have unlocked the cage of time. By mastering the forces of physics, we are recreating the very gates of hell within the confines of our labs. This is the journey of the lab-grown diamond. It's a story of how human ingenuity conquered the impossible to create a masterpiece that will last forever. From the crushing weight of mechanical giants to the delicate precision of atomic rain, witness the birth of a new era in gemstone and technological evolution. Our story begins in the simulation of the
Seeing
underworld.
a consistent rise in the
We
core
are building the
temperature here.
environment where carbon has
Is
no
the cooling
choice
system
but to
engaging
become
properly?
something truly
Affirmative. Flow
extraordinary.
rate is nominal.
Step into the modern sanctuary of science. Here, the air is clean, the lights are bright. But inside these chambers, a violent storm is brewing. Precision is our only tool. Every degree of heat and every pound of pressure must be perfectly balanced to guide the growth of a crystal. At the atomic level, we are forcing carbon to change its shape. We crush the layers of graphite until they lock together in an unbreakable bond. Heat provides the energy for this dance, but we must vibrate these atoms until they find their place in the most perfect lattice known to science. To simulate the weight of the Earth's crust, we use machines that can exert pressure greater than the weight of the entire Eiffel Tower. The environment must be pure. Even a single stray atom of nitrogen can change the color and quality of the diamond we are trying to create. Time is compressed here. What nature takes millions of years to achieve, we must accomplish in a matter of weeks through intense focus and energy. Controlling the heat is as important as creating it. We dance on the edge of destruction, keeping the machines from melting under their own power. Everything starts with a seed. A tiny sliver of a pre-existing diamond provides the blueprint for the new crystal to grow and expand upon. The temperature inside rises to over 2,000 degrees Celsius, hotter than the surface of the sun, at creating a crucible for pure creation. We watch the birth of beauty from behind thick shields, knowing that the forces at play could vaporize anything they touch in an instant. This is HPHT, the most brutal and direct method of diamond creation. It is a sheer display of mechanical force and raw thermal energy. The machines here are the titans of the industry, capable of crushing carbon into its crystalline format in form, using thousands of tons of static force. At the heart of the machine, 6 anvils converge on a single point, focusing all that power onto a space no larger than a walnut. Inside this tiny cell, carbon source material is melted into a metallic catalyst, allowing it to flow and bond with the diamond seed below. The metal acts as a solvent, a liquid bridge that carries the carbon atoms to their new home in the growing diamond crystal lattice. The ground shakes as the pressure reaches its peak. It is a violent, forced birth, where atoms are literally squeezed into their most compact state. Yet we push physics to its absolute limit, maintaining this crushing grip for days or weeks, until the carbon has fully transformed into stone. The wear on these machines is immense. Only the strongest materials on Earth can withstand the pressure they are designed to create. When the process is complete, the pressure is released slowly. A sudden change could shatter the newly formed gem into 1,000 useless pieces. From the heart of the machine comes a dull, unremarkable cube. It looks like common stone, but hidden inside is a miracle of science. As the outer shell is broken away,
the clearest
first
sample
light
we've found
hits the
yet.
raw
Yeah,
diamond.
absolutely
It
flawless.
is the end of a
I'll update
violent,
the manifest.
high-pressure journey. Every successful grow is a victory for the team. We have successfully replicated the power of a plant within the walls of a factory. While HPHT is the oldest method, it remains a pillar of the industry, producing large, high-quality stones for both industry and adornment. As the cleaning process reveals the true nature of the stone, stripping away the remnants of the hell it was forged in to reveal clarity. But there is another way. A method not of force, but of finesse. Welcome to the world of chemical vapor deposition, or CVD. In this room, we don't use crushing weight. We use the power of the stars. This is the realm of plasma and atomic rain. The purple glow is hydrogen and methane gas, energized by microwaves into a state of matter known as plasma, where atoms are torn apart. Inside this storm, the methane molecules are shredded. The carbon atoms are freed from their bonds, ready to find a new place to settle. They fall like a gentle, microscopic rain. Layer by layer, atom by atom, they land on a diamond seed and lock into its perfect structure. This is a dance of chemistry. The diamond doesn't just form, it grows, much like a crystal of ice forming on a winter window. The stability of the plasma is key. Any fluctuation can ruin the growth. They're creating defects that would make the diamond weak or cloudy. We can grow multiple stones at once, ensuring that each one receives the same perfect flow of carbon atoms from the plasma cloud above. The precision of CVD allows for incredible purity. These diamonds are often more perfect than anything nature has produced over millions of years. Computers manage the chaos. They ensure that the rain of carbon is even across the entire surface of the growing gemstone puck. When the process ends, we are left with a clear, flat plate of pure diamond. It is a masterpiece of modern chemical engineering. Now, the raw material must be shaped. We use lasers to slice the diamond plates into the rough shapes of the gems they will become. Only a diamond can cut another diamond, or in this case, a beam of concentrated light can carve through the hardest substance on Earth. And these rough blocks are the foundations of brilliance. They are now ready for the master craftsmen who will give them their final form. At the highest levels of scrutiny, the lab-grown diamond is indistinguishable from its natural counterpart. They are, in every physical way, the same. The journey moves from the high-tech lab to the artisan's bench. It is time to turn these technological marvels into works of art. The jeweler sees the potential within the rough. Every angle and every facet must be planned to maximize the stone's interaction with light. The grinding process is slow and meticulous. Using diamond dust to polish diamond surfaces, we slowly reveal the fire hidden within the stone. Precision is measured in microns. A fraction of a degree in the angle of a facet can be the difference between a dull stone and a masterpiece. As the facets are polished, the diamond begins to sing. It catches the light and scatters it in a brilliant display of prismatic color. But beauty is not the only goal. Diamonds are the ultimate heat conductors, making them essential for the future of high-power electronics and computing. In the hands of a surgeon, a diamond blade provides a level of precision that steel can never match, enabling life-saving procedures with minimal trauma. By pulling heat away from sensitive components, lab-grown diamonds are allowing us to push our technology faster and further than ever before possible. Whether in a supercomputer or on a finger, the diamond remains a symbol of ultimate performance and enduring, unbreakable commitment. The final cleaning removes any trace of the journey, leaving only the pure, brilliant essence of the stone to be admired by the world. The emotional weight of a diamond is unchanged. It represents the same love and the same milestones, now with a story of modern innovation. Thus, can you tell the difference? Even for the most experienced experts, without specialized equipment, these two stones are twins in every sense. The only real difference is their origin. Every lab-grown diamond is laser inscribed, providing a transparent record of its ethical and technological creation. We can even create colors that are incredibly rare in nature.
What do you think of
by
this
introducing
one?
specific elements during the growth process in the lab.
It's exquisite.
Luxury
It suits you
is being
perfectly.
redefined. It is no longer just about scarcity, but about the brilliance of human achievement and the ethics of production. The diamond has come a long way from its home in the Earth's mantle. It is now a product of our brightest minds. Traditional mining has always come at a cost to the Earth. The search for natural diamonds requires moving millions of tons of rock. Lab-grown diamonds offer a different path. By using renewable energy, we can create these gems with a fraction of the environmental impact. That we are powering the creation of the world's hardest material using the softest, cleanest energy from the sun
Look at how the light
and the
hits
wind.
this rendering.
The new
clarity
generation
is
of consumers
perfect.
values
these heat sinks
transparency and
revolutionized the design
sustainability.
completely.
They want their symbols of
setting it-
love to be as pure as the love itself. As we move toward a lab-grown future, we give the Earth a chance to heal. The era of destructive extraction is slowly coming to an end. Innovation is spreading. From New York to Shanghai, The technology to grow diamonds is becoming a global standard for excellence and ethics. We are teaching our children that we can create beauty without destruction. This is the true legacy of the lab-grown diamond journey. In the future, diamonds will be the heart of our most advanced computers, helping us solve the world's most complex problems. From the crushing pressure of mechanical giants to the ethereal dance of plasma, we have mastered the forces that shape our universe. It is a journey of intelligence, to persistence, and beauty. A journey from the depths of destruction to the peak of eternal perfection. The journey from pressure to masterpiece is complete. We have captured the spark of the stars and made it our own, forever.